All right, so you should all have this in front of you, 6.02. And I'm recording, so this will be available in the Google Classroom later. For this one, we're focusing on slopes again. So you might already know quite a bit about them. Well, now we're doing a little bit more. So first, we are just finding the slopes of lines. And it has this formula next to it. Y2 minus Y1 over X2 minus X1. What's another formula for slope that we've learned? Rise over run. There is also change in Y divided by change in X. They're all talking about slope. I would say the first one's easier when it's 2 points that they're giving you. The second one I think is easier if it's a graph. And then this last one is easier if it's a table. So which one do you guys want to use? There's no wrong answer. So rise over run. So when you're doing that, you're counting your rise would be the up or down movement. Your run would be the left or right movement. Now, you really should always be going to the right. You should always be going from the point that's on the left to the point that's on the right. And they specify point A, B, like it really doesn't matter. Like you could have made a smaller triangle and probably gotten the same answer. We'll just use their point. So my rise, my up or down movement, what is my rise? So I heard 2 and I heard 3. So going up, I'm going up 1, 2. So never count like where you're starting as 1. Count like one full box as 1 and then 2. And then what's my run? 3. So then put it together, rise over run, it's 2 over 3. You did 3 over 2, you just flip them. It should be rise over run, rise over X. Good there? Okay, now looking at this one, even before I make my triangle, and it doesn't matter what way you make your triangle. You can make it this way, or you can make it underneath. It's the same answer. But even before looking at it, what should my slope for this one be? It should definitely be negative. Going from left to right, I'm going down. So that's a big indication there. But if you want to make a triangle so you can better see your rise and your run, what's my rise? -2 because we're going down. And then what's my run? 3. Questions on that? Are these negative reciprocals of each other? Yes. Okay, 1 vote for yes, any for no. Are these negative reciprocals? They are not. Why not? Well, it would have to be flipped for it to be a reciprocal. Okay, so yes, it is a negative version of the other, but it's not a reciprocal. So these 2 lines would not be perpendicular to each other. Just kind of testing you on that. But yeah, those are my slopes. Good on that? Okay, so then on to the next one. Now we're finding the slopes of when it's just a horizontal line and when it's a vertical line. We touched on that before. If not, if you don't want to find it in your notes, I think it's easy enough to figure out. If slope is always rise over run, does this one have a rise to it? Does it go up at all? So my rise is 0. My run, I suppose you could count like 1, 2, it doesn't really matter. Because 0 divided by any number is, so my slope for that one is 0. For this one, again, you can memorize it. The vertical lines always have this kind of slope, or you could just figure it out. Does this one have a rise at all? Yeah. So we could give it a number. I could give it 2 since it goes up 2. It doesn't matter. Does it have a run? So 2 divided by 0, what's that? It is not 2. It's not zero. It is undefined. Don't believe me, put it in Desmos, it'll tell you undefined. Or if you put in another calculator, it'll probably give you like an error message. So you can't divide by zero. So you can memorize it, vertical lines are always undefined, you can just know where to find it in your notes, or you can just reason it that way. Put it on that one. Okay. So then, now parallel and perpendicular lines, we've been talking about those quite a bit, but now here's some nice definitions in your notes. So we have parallel lines. They never intersect. Why do they never intersect? Other than that, they're parallel. Because they have the same slope. That is why they never intersect. They have the same slope, different y-intercepts. Because if they have the same slope and same y-intercepts, then it would be the same line of parallel line. All right, so parallel lines have the same slopes. They cross the y's at different places. To prove that they're parallel, so don't just say, oh, because they're parallel lines. All right, now when we get to the proofs. To prove that they're parallel, you could see if their slopes are the same. So you could find the slopes of them individually and see if they're equal. So like take a moment right now, don't shout it out, but find the slope of each line. Find your rise over run over each line. And don't shout it out. Okay, Mark, what's the slope of line AB? So the parallel line. All right, anyone disagree with that? Okay, it is 3/2. So yeah, count your rise and your run. Good thinking on the fly. Let's make sure we're paying attention and not on our phones. But yeah, 3/2, and then when you measure CD, is it the same slope? Yeah. Good. Rise is also 3, run is also 2. So that proves that these are parallel because they have the same slope. Perpendicular. We talked about that quite a bit too. So they create a 90-degree angle. And what do we know about their slopes? They are negative reciprocals. So the sign will always be different. And they'll always be flipped. All right, so if it started out positive, it will become negative. If it started out negative, it will become positive. So they should always have opposite signs. So that's a big giveaway. And then of course be flipped. So yeah. Because you could have two lines intersect and it not be perpendicular. Questions on that? All right, someone tell me the slope of this AB. So -2/3. Anyone disagree with that? AB is going up from left to right, so it should definitely be positive. And aside from that, do we have the rise and the run in the same place? Or in the right place? What should it be for AB? Okay, good. So for AB, the slope is 3/2. Rise over run. Rise is always going up, so 1, 2, 3. And then run is going to the right. All right, the negative reciprocal of that. One, it started out positive, so my negative reciprocal should be negative. And then flip the fraction. So maybe we were looking at the other line, but for CD, that slope is -2/3. Okay, questions? Alright, so let's see if you really know it. What if my slope is 7? What's gonna be my negative reciprocal of that? A line perpendicular to this line would be a slope of, someone said -7, not quite, but the negative part is good. Did I hear the answer? -1/7. Alright, so let's see again. What if it's -4? What would be the negative reciprocal of that? Okay. I've not heard the right answer yet. 1/4. So it should always have the opposite sign. If it started out negative, it should become positive and be flipped.
Afternoon, Darian, excuse the interruption. We're almost at the end of day 2, so you're already halfway through week 4.
Let's one more reciprocal just so we could get like everyone got it right. Let's do if it's 1/2. What's the negative reciprocal of that? Anyone disagree? Could I also put just -2? That would also work. All right, questions, comments, good with negative reciprocal. Okay. So equations of lines and slope. So you're probably familiar with slope-intercept form. If not, star and highlight it. That's y = mx + b. And we call it slope-intercept form because you can clearly see two things. What's one of those things you can see? When there's numbers in it. The slope. And what's the other thing? If something's in slope-intercept form, I can see the slope and the y-intercept. So it's in the name. Slope-intercept form. I can clearly see the slope and the y-intercept. They replace the m and the b, the y and the x are usually just y and x. So yeah, there's other forms, and one of those forms is point slope form, which you might have saw on your first quiz. If so, you know, it might have been an error. Either way, you'll have a chance to retake your first quiz tomorrow. But regardless, here's your point slope form. So it's a different way of writing a straight line. All of these being straight lines. X1, Y1 would be a given point, and M is your slope. So when you're looking at this, there'll probably be numbers where the X1, the Y1, and the M are, the X and the Y just say X1. So for example, we have a slope of a line is 5, and a point on the line is -2, 3. We're going to write an equation of a line parallel to the given line. And also contains the point 3, 4. So work smarter, not harder. First, figure out what they want. They want the equation of a line that would be parallel to the first line. So what do we know about parallel lines? They never intersect because of what? They have the same slope. So if the first part tells me that it has a slope of 5, I don't really care what point it goes through. Does that make sense? Like I could make that equation, but I already know what the slope is. So I know that a line parallel to that line should also have a slope of 5. All right, but it also gives me this other criteria that it has to go through this given point, 3, 4. So should I use y = mx + b, or should I use the y - y1 = m parentheses x - x1? Which one gives me a point and a slope? Good. That one gives me a point, doesn't necessarily have to be the y-intercept, and I know it's not because it's 3, 4 instead of like 0 something. But since it gives me the slope and a point, then I can use that. If it wants it to go through this point, then I can make that point x1, y1. And then now I know what my m is, I can just plug it in. So it's gonna be y minus y1, what did we say y1 is? Good. Equal to m, which we should know what m is, what is it? 5. And it's the same because it's parallel, they have the same slope. If it was perpendicular, then we have to do the negative reciprocal, so it's not. All right, and then parentheses, x minus x1, what's my x1? 3. Now, if it just wants an equation, like doesn't really specify whether it's point slope form or slope intercept form, then we could end it there. But I do think on at least one of your quizzes, it wants it in slope intercept form, so let's do that. In slope intercept form, what is alone? In y equals mx plus b, what is alone? Good try, but no. The y is alone on one side. I do have a y in this formula. It's not alone, no. If I can get it alone, then I can make it into slope intercept form. First, though, we'll probably have to distribute, because if you notice in slope intercept form, there's no parentheses. So we'll have to distribute that 5. What's 5 times x? It is 5x. And 5 times negative 30. Negative 15. On the left side, I still have y minus 4. How can I get the y alone? I could add 4. So use your inverse operations. Opposite of minusing 4 would be to add 4. And whatever you do on one side of the equal sign, you do to the other side. So now y is alone. On the right side, you need to combine like terms. So that means if all the x terms will go together, and all like the single numbers will go together. Does a 5x have a like term? No. Does the 15 have an x? Does the 4 have an x? So then just 5x. Negative 15 and 4. Since those are single numbers, you can always combine the single numbers with negative 15 plus 4. Negative 11. So if it wanted it in slope intercept form, then do that. If it doesn't care, if it wants it in point slope form, then you can just stop there. But it just depends on your answer options. So questions on that thing. Okay, see what's next. So next one, we may or may not have time, we'll see. Find the equation of the line written in point slope form that passes through the point 1, negative 6 and is parallel to the line y equals negative 8x plus 3. So it wants it in point slope form. What's that formula? Good. So it should be in that format. In that formula, only 3 things get replaced with numbers. And it's the y1, the m, and the x1. The x1 and y1 come from what? Okay, what will be like my y1, for example? Okay, good. So the x1 and y1 come from whatever point they want you to put it through. So label it. Notice that in here it wants the y1 first. So yeah. We don't know the slope, or we should be able to figure out the slope. If we want it to be parallel to this line, then what should my slope be? -8, because parallel lines have the same slope, so if it has to be parallel to that line, it should have the same slope as that line. And then the x1 we got from the point. If there are double negatives, you should really fix that. What happens to the double negative? Becomes a positive. So in point slope form, this would be the final answer. With this first part fixed to have a plus instead of a minus a negative. Although they really do need to think. So just have that, we'll end it there, don't lose your notes, we'll finish them together, although you might be able to finish them on your own, and get started on the practice for it. Definitely don't lose your notes, because your practice is in these notes, it's not a separate practice.